addressing mode is nothing but indicating a way of locating data or operands. So in 808 in a computer or microprocessor system, the microprocessor can access data from registers or maybe immediate data or from memory or from IO ports anywhere. So we have to locate where is the data in a proper way. So here the addressing modes describes the type of operands. Operand is nothing but whether the operand is data is in registers, memory or immediate or IO port, and the way they are accessed for executing an instruction. That is we call it as addressing mode. According to the flow of instruction, flow of execution, the instructions may be characterized as two types: sequential control flow instructions and control transfer instructions. Two types of instructions. So coming to sequential control flow instructions, right? Which are these instructions are instructions which after execution of every instruction the control will transfer to next instruction. And you can see in the example, next instruction appear immediately after it in sequence. So example, data transfer instructions, move, push, pop. These are the examples for sequential control flow instructions, even addition, right? Arithmetic instructions and logical instructions. Coming to the control transfer instructions, on the hand, the transfer control to some predefined address or the address somehow specified in the instruction after their execution. So, for example, int, call, read, return, loop, right? Jump instructions. You will see here in this program up to move CL, it is sequence, and coming to up to INCSA, it is sequence. After execution of loop, the control will be transferred to label next and next here, and it will execute these instructions. Actually in sequence int03 is there, but the microprocessor will not execute this one, it will go to here. So this is called control transfer instructions. So the addressing modes for sequential control transfer instructions are, there are 8 addressing modes: the immediate addressing mode, register addressing, direct addressing mode, register addressing mode, register indirect, indexed addressing mode, register relative addressing mode, based indexed addressing mode, relative based indexed addressing mode. Let us see immediate addressing mode. In this type of addressing, immediate data is a part of the instruction and appears in the form of byte or word. The bytes, that's maybe 8-bit data or 16-bit data. In this mode, we can't use instruction pointer register and segment registers. Except segment register IP, we can use all the registers. For example, move AL, 05, move X, 005. So in these examples, the data will be transferred to the X register. Coming to the next, direct addressing mode. So here, the data is present in memory. It has an address. So in this direct addressing mode, a 16-bit memory address, that is offset address, is directly specified in the instruction. It is a part of it. For example, move AL, 5000H. You can see here to get the data, to access data from the memory, 8086 generates physical address, 20-bit physical address. How it can generate physical address? The data is present in data segment, so it requires the base address of the data segment, and offset address is specified in the this instruction. Offset is here, so it will calculate. It will get the offset address from the instruction and adds data segment register contents. It will get a physical address like this. Another example. This is another example. This is the formation of physical address for this instruction, for this addressing mode. And next one is register addressing mode. So register name itself indicates the data is present in register. So the data is stored in register, and that is referred using a particular register. That is the register is part of the instruction here. Here also, except IP, we can use any all the registers except IP. We can use other registers. Even flags also we cannot use flag, except flag and IP we can use other registers. Here, for example, 8-bit data ALCL, 16-bit data X, BX. Coming to register indirect addressing mode. Here the data is present in memory, so we are specifying the address of data through register. We are specifying address of data through register, right? That's why it is we call it as register indirect. So we are using register to specify the address of memory. Okay, so we can use base register. BX, BP, index register, SI, DA registers to specify the address. These are the examples for that. So to form physical address. So here the 8086 microprocessor will get the address from the instruction. It may be base or index, and it will get the it will be added with the DS register, and will get 20-bit physical address. And next one is indexed addressing mode. In this mode, offset address of the operand is stored in one of the index register, SIR, DA. It is similar to register and directory mode. Here we can use only specifically index registers. That is only SI or DA register we have to use to form physical address. And coming to this, next one is register relative addressing mode. So here what happens is this displacement will come into the picture. So to get the physical address, that is address of data, the microprocessor adds the contents of index register or base register, and it can add 8-bit or 16-bit displacement with the offset address, and then adds with the data segment contents, that is base address. You will get physical address.